Hello, this is Segui, and this is a progress report for Show Flu Hazard story for Team Locals Group and Product Owner Dr. Masoud Sadjadi. This is the current information show from Flu Hazard on the Bridgestone database production. And what it does is that it creates this polygon for the county or a portion of the county, and it queries the database for the events that occur in that within those lines. Uh, this is some progress, but it's not effective enough, and it's not as helpful for renters or buyers. Because let's say somebody wants to buy a house in Kendall, it may be a very low rating, but because this the place that is query includes Miami Beach, which might have a really high flood rating, he might not decide to not, or he might think that in this place there's a high flood rating when it actually is not. A very effective way to create this flood view is the way that Trulia does it, as seen here, which actually shows all the areas that have risk of floods, which actually are the ones that need to include flood insurance. So I was very curious of the way they did it and where did they get this information, because it has to be provided by some federal source, and I quickly found OpenFEMA. But OpenFEMA has like a lot of information, different APIs that you can use and everything. And after going around and checking the information that they had, I saw NFHL. NFHL is mostly like a composition of all the information in OpenFEMA and presenting in a view of some layers, eh, which are very helpful. So this is the way that it looks. This is just really the fluid layer uh, layer, the fluid zone layer, because it has a bunch of layers that you could use, but this is the one of your interest. So if you see this, sorry, if you see something like this and you compare it with Trulia, you will see that it actually matches in the areas that. So I thought that Trulia would have been used this information, or regardless, this information could be used to generate some map similar to the one that Trulia is using, and it's open for anybody to use. So I was very curious about this. I decided to explore it further. So this is the way that they say that the data can be consumed. This is just using the map, and this is just downloading a file that you can use to print a physical map. So that's not what we're interested. Besides that, it mentions that you can do search or product on MSC, which stands for Map Service Center, to download some data, some GIS file for your county or your state. I was also looking the way Trulia does it, which is very interesting, and I came across this article. And they mention that they import a shapefile to their database using certain information. So this matches with the fact that to consume the data from an FHL, you have to download this file from the searchable products. So I went on this link on the map service and searchable products, and then selected Florida. Then here doesn't matter the county or the community, because I'm interested in the data for the whole state. And then there's these effective products, and this includes the NFHL state data. So I downloaded this file, which as you can see is almost 2 gigabytes big, but this again includes the data for all these layers, and we're really using just of this one layer to some layer zones. So I downloaded the file, then I was looking at how to consume it, and this is very interesting tutorial by Django on the official site, and they mention how to see these files, which is really they're talking about shapefile, which includes just one layer, but it's not that different from the file that we download that includes many layers. So I try using this org info, the -so, as you can see here. you can do that on the file that you downloaded, and you will get all this information, which is all the layers contained within the file, within the file that we downloaded. I'm really interested in this one, 45, which is floods hazard area. So you can get information for that layer, and then this comes out. This is the information from the shapefile, and the format in which the information is gonna be consumed. So one thing is that the geometry is a multi-polygon, which is this geometry field. Then it has 37,000 features. I mean 379,000 features. And then a really important part is that it uses NAT83, which is the SRI ID for this file. And this is very important because this is not the default. This is used for North America and Canada. So it's gonna have to be included everywhere when we're creating the models and serializing the data and the view and everything, and doing the queries. So if you come a little bit more to the bottom here, they talk about creating the geographic models, which extends from GIS and not the default models. And I have it right here, the models, which is the one from GIS. And as you can see here, this is 3084 is the SRID that corresponds to NAT83. And this is the geometry, which is the multi-polygon field. All the rest are just strings or subfloats. And this is just some general information provided by an FHL. So after that, after you create the model, they make the migrations, you migrate the data, you get this database and this table, which has all this information. And this is the geometry field, which is encoded in this format. You can see it can be very big with a lot of polygons because it's a multi-polygon. And what is left now is to import all the data, which I use using Augur to Augur, OGR to OGR, and this command, which can also be used to use simply after the migrations are done in production, to just import this data to production. We have to actually replace this data for the actual production data. So, and then going further with the code, I have to do these serializers, which extend from geofeature model serializer and needs to be specifies this geofield. These are the fields that are not always known, because if you see the database, some of them are known, but even if they are known, they might not be always be known. So I use query database for all these fields and found that some of them actually had values at some point, but there were like a couple of them that didn't have value at any point, so I didn't think it was useful to output them, so I filter them here. And this is the views. This was very important because the default renderer had some bug that couldn't deal with the geometry, and yeah, that bug was already fixed, but it's still it's not, the fix is not in the version that we're using. It's in a very newer version. So, and this is the views. What I'm getting is I'm getting these four fields: north, south, east, and west, which are the boundaries of the where I want to get all the polygons. These are in longitude and latitude, and it's formed like a rectangle in the map. If I get any error, I print it to the console, so we get a feedback, and I'm also returning a 400, which is a bad request, and send back some message so whoever is consuming this knows that they didn't send the right data. And with this data, I create these corners, which is very important to notice that it's west north or northwest, because longitude comes before latitude for this to creating these polygons and geometry fields. And then it's northwest, northeast, southeast, southwest, and then northwest has to be repeated because it has to be a closed figure to be a polygon. So with that, I create a polygon, and again you can see SRID 3084 for the polygon. And then I create a query set, which is a special query set, as you can see by contain, which means that the whatever feature that we're looking is contained within this polygon that we created based on the information that we received from the request, and then I send the data back. Just to finish up, this is how it looks for these fields. North. This is approximately around this rectangular area, and it returns around 150 figures. This is our, come on. This is the coordinates for the multi-polygons, and this is just some more information that it has. And this is how it will look for an invalid request. As you see, is L. It's loading. Says invalid request, require valid latitude and longitude. And it inspects network. We see that it's a 400 byte request. Which one of the issues that we saw is that the backend always, or most of the times, just sends 200 okay, even though the request might not be really valid or might just not find anything. And that's all. We can be contacted. My name is Segui, and this is my email, fsegu004@fiu.edu, and the product owner is Masoud Sadjadi, and it can be contacted at sadjadi@cs.fiu.edu if you have any questions. Thanks so much.